say first what most of my colleagues say. 99% are, again, assuming that space-time is fundamental. Particles in space-time, matter is fundamental. And most are reductionist. And so the standard approach to consciousness is to figure out what complicated systems of matter with the right functional properties could possibly lead to the emergence of consciousness. That's the general idea, right? So there's many, many theories of this type. What's common to all of them is they assume that space-time is fundamental. They assume that physical processes in space-time is fundamental. Panpsychism adds consciousness as an additional thing. It's almost dualist in that regard. And my attitude is our best science is telling us that space-time is not fundamental. Quarks, leptons, and gluons are just irreducible representations of the symmetries of space-time. So the whole framework on which consciousness research is being based right now is doomed. And for me, these are my friends and colleagues that are doing this. They're brilliant. They're brilliant. My feeling is I'm so sad that they're stuck with this old framework, because if they weren't stuck like with earth, air, fire, and water, you could actually make progress. So it doesn't matter how smart you are. If you start with earth, air, fire, and water, you're not going to get anywhere, right? What is doomed, in the sense that it's wrong, is reductionism.
Which is saying space-time is fundamental.
Right. The idea that somehow being smaller in space and time, or space-time, is a fundamental nature of reality. That's just wrong. It turned out to be a useful heuristic for thermodynamics and so forth, and several other places reductionism has been very useful. But that's, in some sense, an artifact of how we use our interface. But the idea that we're getting to the more fundamental nature of reality, no. When you get all the way down in that direction, you get down to the quarks and gluons, and what you realize is what you've gotten down to is not fundamental reality, just the irreducible representations of a data structure. That's all you've gotten down to. So you're always stuck inside the data structure. So you seem to be getting closer and closer. I mean, I went from neural networks to neurons to chemistry, chemistry to particles, particles to quarks and gluons. I'm getting closer and closer to the reality. No, I'm getting closer and closer to the actual structure of the data structure of space and time, the irreducible representations. That's what you're getting closer to, not to a deeper understanding of what's beyond space-time.
Well,
so most of my colleagues are saying, let's start with matter or neurons and say what properties of matter